All right, so imagine this. You've got a huge technical interview coming up. The topic? Retrieval-Augmented Generation, or, RAG. You really need to sound like you know your stuff, right? Well, that's exactly what we're going to do today. Think of this as your personal coaching session. We're going to completely demystify how RAG works, starting with the absolute most important part of the whole system, retrieval. Ready? Let's get into it.
So the best way to wrap your head around a RAG system is to picture an AI taking an open book exam. It's got this massive library of information right at its fingertips. But when you ask it a question, how on earth does it find the exact right page in the exact right book, like instantly?
Well, the secret, it's a component that acts kind of like a super fast, hyper-efficient librarian. It's called the retriever. And honestly, understanding what it does is the real key to mastering RAG. So, let's get down to it. What is the retriever's core job really? Its function is very specific, and it is absolutely crucial to making the whole system sing. Now, what's so important to see here is just how clear its role is. The retriever, it doesn't generate answers. It doesn't get creative and write anything. Nope. Its one and only job is to find the most relevant pieces of information and just hand them over. It's the bridge, right? It connects your question to the knowledge the AI is going to use to answer it.
And here you go. This is your polished, interview-ready answer. Using a phrase like abstracts the logic, that shows you get that it's a clean interface hiding a ton of complexity underneath. It makes digging through a complex vector database feel simple.
So how does it actually work? Well, the most common type is a vector store retriever. First, your question gets turned into a long string of numbers. That's an embedding. And that string of numbers captures its meaning. Then, the retriever just scans its whole database of document embeddings, looking for numbers that are mathematically the most similar. It grabs those matching documents and sends them on their way. It's really all about finding the closest meaning.
But, just finding documents is really only the first step. To get the best performance, you need to find the right number of them. And this is where we get into tuning your retrieval, and it's a really delicate balancing act.
The main dial you can turn here is a little parameter called K. It's actually super simple. K is just the number of documents the retriever is going to go fetch. So if you set K to 3, you get the top 3 results. Set it to 10, you get the top 10. It's a tiny setting, but it has some pretty big consequences.
And this right here, this is the classic trade-off. Think about it. If your K is too small, the AI might miss that one golden nugget of context and give you an incomplete answer. But if you crank K way up, you risk feeding it a whole bunch of irrelevant noise. That can confuse the model, or even worse, you might just run out of room, exceed its token limit. So the whole game is about finding that sweet spot.
Okay, so you set your K to, let's say, 3. But what happens if the top 3 most similar documents are, well, basically identical? They're just rephrasing the same point over and over again. You're not actually getting new information. You're just getting redundancy. And this is a super common problem. So the solution is this clever technique called Max Marginal Relevance, or MMR. Regular similarity search just blindly grabs the most similar stuff. MMR is smarter. It picks the most relevant document first, sure, but then, for the second pick, it looks for something that's also relevant but different from the first one. It's designed to prioritize both relevance and diversity, which gives the AI a much broader context to work with.
Okay, let's level up and look at some more advanced search strategies. Because searching by meaning, what we call semantic search, is incredibly powerful, but it's not always enough. Sometimes you need more than just the general vibe, you need the exact words.
And this is where hybrid search comes in. It's really a best of both worlds approach. It combines that powerful, meaning-based semantic search with the good old-fashioned precision of keyword search.
And here's why that's so important. If your question is a concept, like why is my system crashing, semantic search is going to be perfect. But what if you're searching for something specific, like a product ID or an error code like XJ1289? You need an exact match. Hybrid search lets you handle both kinds of queries gracefully, which for real-world applications is a must-have.
Now we're getting to the final polishing steps. So once you have a good set of potential documents, you can use filtering and re-ranking to make absolutely sure the AI gets only the highest quality context possible.
Metadata filtering is it's an incredibly powerful idea, and it's so simple. Every document can have tags, right? Like the author, the date it was published, or maybe the department it came from. By filtering on this metadata, you can tell the retriever to only search within, say, HR documents from last year. This dramatically improves your speed and your precision just by shrinking the haystack you're searching in. And re-ranking. Think of it like a second, much more careful review. First, you do a quick, broad retrieval to get a short list. Let's say you grab the top 10 documents. Then you bring in the big guns, a more powerful, maybe slower model, to carefully reread each of those 10 documents and score them again with much higher scrutiny. Finally, you take the new, reordered top 3 or 5 and pass only those to the LLM. It's all about ensuring maximum quality.
So why have we spent all this con focused just on the retriever? Because, and this is so important, if your RAG system gives you a bad answer, the problem is almost never the language model itself. The problem is almost always in the retrieval step. If that final answer is just wrong, you have to look at what the retriever found. Did it pull up totally irrelevant information? Did it pull chunks that actually contradict each other? Or, hey, maybe the way you broke the documents up in the first place was just wrong. Inspecting what was retrieved is always the most important step in debugging.
And this is the perfect way to think about it. The LLM, that's the chef. It can only cook with the ingredients you give it. So if you hand it low quality, irrelevant, or incomplete context, you just can't blame it for producing a bad answer. It's garbage in, garbage out.
Which leaves us with a final thought to chew on. We've spent all this time talking about how to perfect the retrieval process to ground our AI in solid facts. But does that precision come at a cost? Is there a trade-off between a system that gives perfectly sourced factual answers and one that has a little more room for creativity and maybe even inference? Definitely something to think about.